Today, I will be presenting some updates on biological control. In the beginning, I'm going to be presenting some information just about the state in general that you may have seen if you attended the meeting in Albany. However, after that, I am going to be talking about some of my more recent research. Some of this is just from March, so it should be new. So if the beginning is a little bit of a repeat for you, don't worry, you will see some new content. So with that being said, I don't plan on doing too much of a background on the Emerald Ash Borer itself, as I'm sure all of you are relatively familiar. Across New York, we had mature, healthy ash trees. We saw these healthy overstories. And just a few years later, after Emerald Ash Borer infestations, we generally see these tree, essentially graveyards. So the reason I'm including this particular picture at the beginning of this presentation is to remind you what the goal of the biological control program is, or perhaps for some of you to let you know for the first time. So when we're talking about the biological control of Emerald Ash Borer, we are not talking about trying to prevent this picture. This picture is essentially inevitable in a lot of cases. Mature trees are going to die, and that is just due to the fact that there are hundreds of thousands of Emerald Ash Borer out there in these mature ash forests. What you'll notice in this picture, however, is that regenerating ash material. You can see some in the background. And that's really what the goal of the biocontrol program is trying to protect. If we can allow these trees to regenerate after Emerald Ash Borer populations have crashed in the presence of biocontrol agents, then we should see continued suppression of Emerald Ash Borer while these trees grow into more susceptible size classes. And so everything that I'm going to be talking to you about today is really focusing in on these smaller trees and what's going to happen in the future. That being said, in 2021, Emerald Ash Borer is a statewide problem. Different counties are at different states in the invasion process. However, throughout the state, we have a lot of knowledge to share. So if you're in a county that is experiencing Emerald Ash Borer infestation more recently, definitely don't try to reinvent the wheel. There are a lot of people throughout the state who can help you out with this process. And these 4 counties theoretically don't have Emerald Ash Borer, but I'm sure all of you are aware when you see a map like this, it's either inevitable or it's already there. So moving on to our biocontrol agents. I was just told that Genesee County is going to be experiencing some releases this upcoming summer, so I crossed it out. There may be some other counties that are going to be experiencing parasitoid releases in the future. However, as of 2021 on Map Biocontrol, where we keep track of our parasitoids, and I will be going into more depth about these parasitoids in a second, 38 counties so far have had biocontrol agents released. The counties that you see listed on your screen are the ones that are still lacking releases. So that's a pretty good spread across the state. Obviously, we want to keep filling this in. If we look at where ash has historically been dominant throughout the state and overlay that biocontrol map, you see that we did hit a lot of areas that had high proportions of ash. There are a few counties, although Genesee County, again, can be crossed out, where we do want to really focus on biocontrol releases. And I do think a few of these counties may have some plan for the future. But if you're in these counties, I definitely would recommend looking into biocontrol. There's probably suitable field sites relatively easily found. So when we're talking about the actual biological control agents, the first one that we're talking about is Tetrasticus planopenisi. So this is a late instar Emerald Ash Borer parasitoid, which means that it can only go after Emerald Ash Borer, which have been feeding in ash trees for quite a while. They've grown to a larger size class. These have been released in New York since 2011, and you'll see that we have released 410,000, a good number, in the past decade. Tetrasticus, however, does have a relatively short ovipositor. And for those of you who are less familiar with insects, these 2 videos here display a native parasitoid not going after the Emerald Ash Borer, but you can see that long ovipositor structure, which is allowing it to essentially drill through the bark of this tree. And what this does is allow it to gain access to whatever is underneath that bark that it would like to lay its eggs in or near. So you can see, based on this native parasitoid, the advantage of having that long structure. It really isn't limited by the size of the bark on that tree. When it comes to Tetrasticus, however, where we do have this short ovipositor, it really is limiting its impacts to the smaller trees throughout the state. And that's great for right now when we're really focusing on ash regeneration. However, as we're moving forward and these trees are regenerating, we're really going to need to focus on some other parasitoids. And I did just see quickly in the chat, I'll address it now. Those counties are probably going to be participating in the future. They just hadn't experienced releases, as far as I know, at the current time. So Tetrascus planopenisi have been released in 38 counties so far across the state. The next parasitoid is Ovius grilli. This is an egg parasitoid, which is fantastic because it means it's going after emerald ash borer before any damage has been done. It's going after the eggs. It's been released since 2012. However, it's relatively cryptic because it is an egg parasitoid. As you'll see later, it's really easy to find these larval parasitoids, but emerald ash borer eggs are really small. We've confirmed its persistence in the environment in a lot of cases, but it's a little bit harder to quantify their impacts. There are some studies in the literature that have taken that on. However, I'm not going to be talking about it much more today. And Ovius grilli has been released in 31 counties. Spaceys Gallini is the last biocontrol agent we're going to be talking about, and this is another late instar parasitoid. However, it does have a longer ovipositor, which means that it's not going to face that same problem that Tetrascus faces. And it's been released since 2016, and you'll notice only about 60,000 have been released. So it's relatively new, it's relatively recent, but as these trees are hopefully regenerating, we're really going to have to look at getting Spaceys Gallini out there on the landscape to really protect them as they become too big for parasitism by Tetrascus. And since it's newer, it's only been released in 29 counties. So this is one that we really, really want to see getting filled in on this map. So as I mentioned, this all has to do with ash regeneration. We're not necessarily trying to protect these mature trees. And so I'm going to talk to you today about a study that is looking at ash persistence and regeneration. Without this, there's no point in pursuing biocontrol if there isn't anything to protect on the landscape. So this particular study looked at ash trees in Ulster and Greene County in eastern New York and Cattaraugus County in western New York. And what we did was we looked at tree health in 2013 and 2022 and just tried to establish whether any trees were persisting through emerald ash borer infestation. We assessed the health of these trees in 5 sites in eastern New York, 6 sites in western New York. And if you look at this photo, you'll see essentially what we're assessing when it comes to canopy condition. That tree in the center is actually in Syracuse, New York, but it's perfectly healthy. It is a canopy condition of 1. That tree right next to it, which is obviously not so healthy, would probably have a canopy condition of about 4. It's nearly on its way out, with a canopy condition of 5 being complete mortality. So we're really ranking on this 1 through 5 scale. And now that I said that, I'm going to show you a figure where it's A through E instead, but A is 1, E is 5. And so this is looking at these trees, and the 2013 data was provided by Julie Gould and Melissa Furkey. These trees in eastern New York, and how healthy they were in 2013, which is relatively recent compared to when emerald ash borer arrived. So you'll see that we had very few dead trees in that canopy condition of E, but we had a good number of perfectly healthy trees in A and B. These are doing pretty well. So now I'm going to overlay what happened when I went out this past summer in 2021 as a follow-up. So what you're looking at now is the A bar is still all the trees that were a category of A in 2013, perfectly healthy trees. But now everything in black is a dead tree. So you'll see across the board, we had pretty significant mortality, no matter how healthy the tree was in 2013. However, the white coloration is now a perfectly healthy tree that's still perfectly healthy today. So those are only found in those first 3 canopy conditions. So if the tree was already looking pretty bad, a D or an E in 2013, it died 100%. But now we see there are still some trees out there that have persisted throughout this infestation process. But we're not really seeing any intermediary trees anymore. In 2013, B was really important. That B bar is really high. But now B is represented by that blue coloration. And you'll see there's barely any of this intermediary canopy class. And so what it's really looking like is trees are either dead or they had perhaps some resistance or some site characteristic that allowed them to persist. And they're doing pretty well, but it is a very small proportion of these trees. And when we look at Western New York, we're really seeing that same trend where we either have perfectly healthy trees in white or dead trees in black. We're not seeing those intermediary colors representing intermediate health conditions. And these were mature trees. So that means, we do have some mature trees out there that could perhaps be a source of regenerative materials. And so when we actually look to quantify, is there still ash regenerative materials at these sites? At each site, we did some transects, just looking at how many saplings and seedlings are out there. And when we actually look at that, at trees that are less than 2.5 centimeters DBH, when we look at seedlings, in Western New York, we do see a slight decline. It wasn't significant, but there are still a good number of seedlings out in both Eastern and Western New York. When we look at a slightly larger size class, 0.5 meter to 1 meter tall trees, we are seeing an increase, a general increasing trend. It's not significant, but there are these saplings out there. And finally, for saplings that are taller than a meter in the Hudson River Valley, it actually was a significant increase in these trees. And Randolph wasn't quite significant, but we're seeing a general trend of increase. And so what we're seeing is that there is regeneration occurring in general. The seedlings could be growing into these larger size classes, or they're essentially being shaded out by these larger cohorts. But there are ash trees out there to protect, and mature trees are still persisting to provide future generations. But none of that matters if the emerald ash borer isn't going to just move into these trees and kill it off. And so in order to actually assess whether these are going to regenerate, we had to look at the mortality of emerald ash borer. So you'll notice we still have some of those same counties colored in on this map, but we also added in Steuben County and Erie County, just to get a feel for what's going on with the emerald ash borer itself. So in each one of these 4 regions, the Eastern New York region being 2 counties, we looked at 3 field sites for this study. And what we did is we actually established a cohort of emerald ash borer that would be easy to follow. So we obtained some eggs on coffee filters. You know, they come in these little strips. You can cut them up so you have 1 to 5 eggs on a little coffee filter. And we actually glued them to ash trees at each of these sites, 10 trees per site. And this allowed us to just keep track of a known quantity of emerald ash borer. And we did, you can see a strip up there on the top of that tree, that's 5 eggs, another strip a little bit lower down of another 5 eggs. So a total of 120 trees between all these sites. And they're all relatively small trees. You cover them up to try to protect them from the environment, covered in tree wrap to protect it from predators who might be trying to get at these eggs. And the point of this is really just to encourage hatch and to allow these emerald ash borer to infest these trees. We don't want them to get killed by just the environment. However, what that allows us to do is we can then go cut down these trees and quantify what's happening in them. So we did this twice. In 2019, we put the eggs up in May. We cut them down in March of 2020, which unfortunately meant I had to do all the lab work in my living room, which was quite a process. But this past year, 2021 to 2022, you know, I got to do this in a nice lab space. It was quite a bit easier and had far less cleanup in my living room. That being said, when you actually peel back the bark on these trees, it's really easy to see what happened to these emerald ash borer larvae. So in this case, on the left, you're seeing Tetrasticus larvae. You just follow that nice serpentine gallery. And at the end, instead of an emerald ash borer, you have parasitoids. In the center, you have adult Tetrasticus. And on the right, you see a gallery with Spaceys Gallini cocoons. That's that one kind of in the center. And to the left of that, you see a gallery that Tetrasticus has already emerged from, and it left behind those little black specks. And so it's really easy, as I said earlier, with these larval parasitoids to find out if they're present and what's going on. So what this allowed us to do is actually quantify the mortality in these trees. So on the y-axis here, you're going to see percent mortality, and I'm only showing you one site now just to keep it relatively straightforward while I explain what's going on. So this is in those Steuben County locations in 2019 to 2020. And what you're going to see is that we divided the instars on the x-axis into early instars and late instars. And that's just because parasitoids really are only going after the late instars that are large enough for parasitism. On the top of the bars, you're going to see an N value, and that's just how many we observed in that particular size class. And because we don't have any Benjamin Button emerald ash borer, if we saw a late instar, we assumed that it was an early instar from our cohort. And so the 115 that you're seeing for Steuben County in the earlies includes the 35 that made it to later instars. That being said, what you're going to notice right here on this figure is a lot of the early instars are just alive. That's that blue coloration. There isn't that much mortality happening early in their life stages. However, by the time we get to those late instars, Tetrasticus planopenisi parasitism is that orange bar. It's relatively significant, as is woodpecker predation in green, some tree resistance or disease in brown, parasitism by the native Atanicolis parasitoids in red, and parasitism by the other biocontrol agent, Spaceys Gallini, is in purple. And so just filling in that figure with the other locations in 2019, you'll see a pretty consistent trend across the board where these late instars are really being hit by these parasitoids and by woodpeckers. So now we're looking at the more recent cohort that we looked at, and you'll see the trend stayed pretty consistent. If anything, parasitism by Tetrasticus increased throughout the study system between the original 2019 establishment and 2021 establishment. But this doesn't necessarily mean that much if emerald ash borer can reproduce enough to replace all the ones that are dying to parasitism. It seems like a lot when you have 80 or 90% mortality of these late instars, but it doesn't guarantee a decreasing population. So what we actually wanted to do is convert this into something that would allow us to assess, what's going on with these emerald ash borer. Are they going to increase and kill off all these trees? Are they staying stable? And so we converted this into a net reproductive rate. And so what you're looking here would be an example of essentially what these equations are doing. I'm not going to show you the equations, but it allows you to calculate if the subsequent generation is the same as your current generation. In this case, they're both 1. Their reproductive rate is going to be 1. It's staying constant. You're just replacing your emerald ash borer. If the subsequent generation is going to be bigger, so you calculated this is how many died, this is how many eggs are going to be laid, and how many we expect to reach adulthood, that means you have an increasing population. That wouldn't be good news for these ash trees. It means, the population crashed, but now our trees are regenerating. They're not dying enough to parasitoids, and so we're going to have more mortality in the future. But if the subsequent generation is smaller, it means that our populations are staying relatively low, or they're declining even further. And that's really what we want to see. However, when we do these calculations, there is one really big assumption that I need to address, which is the hatch rate of my eggs. So I'm going out there, I'm putting these eggs on trees. It's probably not biologically accurate to assume that we have 100% hatch rate. And if we did, and we only saw one reaching a late instar, that's going to be a really low reproductive rate because you're assuming everything was alive. And so that's artificially low reproductive rates. However, luckily for me, there was a study at a lot of these same sites that did just directly observe the hatch rate of some eggs. And so I'm actually going to report on all of these to you, just because I know we have a tendency to be a bit pessimistic. So even though, a 29% hatch rate would be the highest reproductive value, that's probably not what we're observing. That was just the lowest value that this other study happened to observe at these sites. I'm going to show it to you just so that if you don't want to trust the mean value of 43%, you can kind of see what the worst case scenario is. That being said, if we look at these reproductive rates, the different bars in each county are those different hatch rates. You can see the worst case scenario is in yellow for each region and year. And the best case scenario, the unrealistic one, is in blue. So in 2019, things are looking a little bit rough, especially in Erie County and Ulster and Greene counties. That yellow 29% is pretty high. But what you'll notice is that by 2022, so that's every other bar, across the board, we really have a reproductive rate that's really close to 1, if not below 1 in Cattaraugus County. So, Steuben County is just slightly above 1 in the worst case scenario, Erie County as well, and Ulster and Greene counties also. So, I included this 29% value because it is the worst case scenario probably, but it's also not even that bad given the data that we collected. On top of this, a lot of the larvae that we recovered were not ready to overwinter and mature to adulthood. So emerald ash borer has either a 1-year or 2-year lifespan, depending on how much it can mature. And we're seeing that these were probably all going to be a 2-year lifespan, or the majority of them were going to be a 2-year lifespan. And what that means is that in that second spring, parasitoids and woodpeckers are going to be killing more of those late instar larvae. So the fact that we already see reproductive rates close to 1 with just 1 year of mortality means that we probably can expect realistically that these are going to be even lower with the second year of mortality. So that really indicates, these populations might be stable at 1 or decreasing. And they should already be very low because we've already seen a lot of the mature ash die. So it's really just what's going on in these small trees that's going to be driving this system moving forward. And I do just want to mention, you may have noticed that I didn't talk that much about Spaceys Gallini. If I go back and show you the mortality, there's very little of that purple coloration in 2020, in the 2020 collection. There's none in the more recent collection. This was all driven by Tetrasticus. However, in the literature, we know Spaceys Gallini is really important. But I went out there and when I was collecting trees, I was really focusing on these small trees. And since Spaceys Gallini does have that longer ovipositor, it seems like there might be some partitioning with it going after larger trees. So this is a separate study that I was not involved in at all, but it's relatively recent. And I do just want to point it out to you because it's going to be important in New York. where they actually assessed how Spaceys Gallini was doing on some larger trees. And what this figure is showing is that by 2020, you can see the reproductive rate with all parasitoids in that black line. It's relatively low, between 1 and 2. And if you removed Spaceys Gallini from that system, which is that green line, the reproductive rate is much higher. So what that means is that Spaceys Gallini is making up the difference between those 2 points. It's really having a high impact in that system. So in our system, we confirmed Spaceys Gallini was still there after release. It's just not going after these small trees. So even though I didn't talk about it too much, and it's not necessarily impacting what's going on in our saplings, we can expect that it's going to have an impact as these trees mature, based on this literature and the fact that we just know it's still at these field sites. And I did just want to kind of conclude with some notes on dispersal here. So hopefully what I've done is show you that these parasitoids seem like they're having a big impact. And you may be thinking, oh, there are parasitoids released in my county, but my county's big. So are the parasitoids even going to have an impact where I am if they were released on the other side of the county? And so this is just an anecdote that I observed this past summer. There are some studies out there specifically looking at dispersal, but I had some field sites on the western side of the Hudson River. And these were utilized for release of Tetrasticus early on. Spaceys Gallini hadn't even been approved for release yet. So it's not released at these locations on the western side of the Hudson. But when I was out there this past summer, I found Spaceys Gallini at these 4 locations. The red and the green squares, it's just the way Map Biocontrol reports field sites. You don't have to pay too much attention to that coloration. And the green square that doesn't have a circle around it, indicating Gallini, I didn't go to. So I can't say for sure whether it was there or not. But the obvious question is, how did a biological control agent, not native to North America, get to these field sites if it was never released? And I think the answer is, if we zoom in on these center squares, Spaceys Gallini was released on the eastern side of the Hudson from 2016 to 2019. So that's 3.5 kilometers away over the Hudson River, but relatively close to our field sites. So it seems to me that we're probably observing that this parasitoid has the ability to disperse relatively far distances over, habitat that wouldn't be considered suitable. I don't think there are ash trees in the middle of the river. And most of the ash already died at these field sites. So it found these remnant populations that it could fly to, potentially over the Hudson. I can't say for sure that that's what's happened, but I can't come up with another good explanation of how this biocontrol agent would have gotten to these locations. So that is promising for dispersal within counties, even across county lines, just of these parasitoids and natural dispersal and spread. And the last thing, this is kind of a passion project that I had worked on, and I haven't mentioned Syracuse at all, even though that's where SUNY ESF is. And so I did just want to show you some of the stuff that's going on in Syracuse, because everything I've talked about so far is really focused on, natural forest habitats. So on the left here, you're seeing a map of Spaceys Gallini distribution in an urban environment in the city of Syracuse in 2020. The pie charts represent, how much green space in green versus impervious surface cover each of our traps had around it. If there's a red circle around it, it means we didn't recover Spaceys Gallini. If there's a little parasitoid silhouette, it means we did recover it. And the coloration is potentially not coming through quite well on Zoom right now, but essentially everywhere we recovered Spaceys Gallini in 2020 was a city park. It was not in the urban environment. It was not found on our street trees, which was not necessarily good news for potentially allowing street trees to regenerate and keeping ash in our urban environments. But by 2021, we saw that Spaceys Gallini was perfectly happy dispersing from these parks to all these trees throughout the city. And the other biological control agent, Tetrasticus, had a very similar trend. It was everywhere in the city as well. So this is a little bit of a different system because we're using insecticides to keep trees alive instead of, trying to protect regeneration. But if any of you have ash trees in your cities that have been protected, it is potentially good news for these biocontrol agents in those urban environments as well. We are seeing dispersal both in traditional forests and in urban forests. So with that, I do just want to say a lot of this work has been set up by many people. So we've had plenty of collaborators on the biocontrol project in general. If you are a collaborator whose name is not here, I would love to hear from you so I can get your name on this slide and I can get you represented as working on this project in New York. I especially want to thank Melissa Furkey and Julie Gould for working with me personally and providing me with a lot of the earlier data that I referenced. And with that, I hope I have some time for questions, and I would love to talk about this with you if there's anything you want to know. Thank you all for listening again.